Okay, hello everyone. Welcome to the talk about Lichess, the second largest website to play chess games online. This talk is brought to us by T. Alexander Listed, who is volunteering in the Lichess team since 2015. I will now hand over to him and wish all of you a great talk.
All right, thank you. Good afternoon, everyone. So yes, my name's Alex. I've been with Lichess since 2015. First, I want to ask all of you to raise your hand if you have used Lichess before. Wow, okay. Maybe 75% of the audience, that's awesome. Quickly, for those of you who don't know what Lichess is a chess website. Okay, a few more hands are going up. Lovely. So you can go to lichess.org in your web browser, you can use our mobile apps, you can learn how to play chess, you can study chess to become better, or you can play chess against the computer, against your friends, against strangers. But Lichess is also a couple of other things. For instance, Lichess is also a collection of open source software projects. In making Lichess, we use a lot of open source software, and the software that we make we publish and release under open source licenses. So if you are curious how Lichess works, you can read the code. If you want to improve Lichess, you can contribute, make suggestions. Or if you want to use the code for your own purposes, you can do so too, as long as it's compliant with the licenses involved, of course. Thirdly, Lichess is also a non-profit organization. We are registered in France, and our main mission is to make sure that as many people as possible can learn and play chess. How do we do that? Well, we make sure that Lichess is free for everyone, forever. That means, for instance, that there are no features that you can pay for on Lichess. There are no features that are paid behind a paywall. It's free for everyone to use. A lot of the time, that means that you, the user, are the product, that you are being sold or exploited in some way, but that's also not the case for Lichess. We do not have any advertising on Lichess, and we've made a commitment to never having any advertising on Lichess. But of course, there is a cost to running Lichess. So where do we get our money from? Well, you can probably deduce. We get 95% of our income from user donations. The average donation we get from users is €5.50. So we are fully funded by our users, by the online chess community, and that's the way we like to have it. That means that we're not beholden to advertisers. It means that we're not beholden to investors who want to extract the most profit possible from the user base. It means that we are free to make the decisions we think are best for Lichess and the user base for the long term. The last 5% of our income comes from merchandise. We sell t-shirts, coffee cups, stickers, things like that. And if you're curious what it costs to run Lichess, you can go to lichess.org/costs. That is where we publish a continuously updated budget. So right now you can see that it takes $34,000 or euros, they're about the same now, per month, to run Lichess. Most of that is personnel cost and server cost. So right now we are paying one full-time developer, and then we are paying smaller stipends to about a dozen people. And that obviously means that we are relying on a lot of volunteer work. Lichess would not be possible without the team of 125 contributors, team members, staff members, and volunteers. The 125 people are distributed all across the world, and that includes developers, system administrators, it includes moderators, it includes content creators, and we have experts in different fields. Experts in law, experts in accounting, people with journalism backgrounds, everything that we need. You might be interested to know that the largest of these groups that I mentioned is the moderators. there is a lot of moderation work that needs to happen on Lichess. One part of it is that we have a lot of user-generated content. We have forums where people can post. We have blogs. People can have personal blogs. There's a chat and messaging system on Lichess. So we need to make sure that people are not posting illegal stuff. We need to prevent and stop harassment and abuse, stopping spam, things like that. Then the other part is dealing with a very common problem in online chess, which is cheating. People will cheat in different ways. That's also a big part of the moderation work to prevent and stop cheaters. Of course, we have a lot of automated systems to deal with both of these problems. But still, there are corner cases. There are cases where human judgment and decision is needed. For the simple stuff, that is automated. This means that the moderation team in total takes about 1,500 actions every day. And that ranges from the mildest forms of sanction, which would be warning a user, to the most severe forms of sanction, which would be closing a user's account and preventing them from creating new accounts. To give you a sense of the scale of Lichess, currently there are 4.7 million games of chess being played on Lichess every day. And on a Sunday in January this year, we reached our record to date, 5.5 million games in one calendar day. So now I have another question for everyone who has raised their hand so far. Raise your hand if you discovered Lichess during the pandemic. Okay, maybe, 20%. Well, there were a lot of people who discovered Lichess during the pandemic. If we look at this graph, we see the number of standard rated games played on Lichess since 2016. So you see quite a steady growth, but then you see some spikes. Can you guess what these spikes are? So I heard one already, and I think we all know the other. So the first spike, let's call it March, April 2020, was the global lockdown started. Everyone found themselves inside, and some of us started to play chess or played more chess than usual. Then, yes, in October the same year, Netflix released The Queen's Gambit. I hear people recognize this. For those of you who don't, it is a popular miniseries that features chess prominently, and it became a global hit. So that also apparently inspired a lot of people to try chess or to play more than they did before. Now, as we have been growing since 2016 and before, of course, we have had to deal with different types of scaling challenges. But they have been fairly gradual, and we've had time to identify and fix most issues. With these spikes, that became more difficult. We had more scaling issues in a shorter amount of time than we were used to, and we had less time fixing them. On December 21st, 2021, we had one consequence of that.
So, for those not aware, this is Agadmater Cake Defy Christmas Arena.
So once again, you guys, this is going to be the G Fuel Agadmater Cake DeFi Christmas Arena.
Prize fund is listed here. The total fund adds up to about over $60,000.
Not anymore.
8, 7, 6,
let's go.
5,
Nice
4,
touch.
3, 2, 1, 0.
Let's go. Where's my game? Where's my game?
Oh no, is Lichess crashing? Oh no!
Let's see, what's the chat saying? The chat is going a million miles a minute.
Can I play from my phone? Maybe phone will take up less bandwidth.
Oh, okay. Well, I guess that means we're not going to start, right? Now I hit refresh, right?
Yeah, so this is a day that the team will probably not forget for a while. So what happened? Well, Agadmator is a very popular chess YouTuber. And he decided to use Lichess to organize an online chess tournament. And that's something anyone can do. You can do it as well. What was special about this tournament was the big prize fund, right? Equivalent of $60,000 at the time in prizes. And that attracted the world's best players. Magnus Carlsen, the world champion, played in the tournament. You saw Grandmaster Hikaru Nakamura in the clip. Ian Nepomniachtchi, Alireza Firouzja, and a bunch of the other top 10, 20, 30 players in the world decided to play this tournament. Like, if you win, it's pretty good pay for a 2-hour work, right? But the tournament was actually open for everyone to play. So when this tournament started, it had 19,000 players. And unfortunately, the tournament suffered multiple problems. So what you saw in the beginning there was, when the tournament starts and the countdown hits 0, what you expect is that all the players in the tournament are paired up and all their games start. And normally that's, basically instantaneous. But it was not in this case. Now, we were able to fix this problem on the fly. So we restarted the tournament just a couple of minutes later, and everyone rejoined the tournament, and the tournament was started successfully. So everything's good, right? No, because after about 1 hour of play, the tournament failed again. And at that point, it was unrecoverable. It was not something we were able to fix on the fly. So we realized we had to abort the tournament, which of course was super disappointing for the players, for the spectators. They had tens of thousands of spectators as well, on the site, on Twitch, on YouTube, etc. But we had to abort it. And we were hoping that we could either resume or restart the tournament in a few days. So of course we started investigating what was the problem. And I'll explain what the problem was. So when players play tournaments on Lichess, they generate a bunch of events that Leela, which is the core of Lichess, needs to process. So players will join tournaments, leave tournaments, they will be paired up, games will start, games will finish, players will be given points for their wins. And these events needs to happen in a certain sequence, so to avoid race conditions. So to manage that, every tournament had its own in-memory queue where these events were put, and Leela was processing these events in sequence. Now the problem was that for the first time ever during this particular tournament, the rate at which the events were generated was higher than the rate at which Leela was able to process those events. So the queue never became smaller, it only grew. And that's what ultimately caused the tournament to fail. Now, what was the fix, right? We then tried to figure out how could we fix this, and we did 4 things. So first of all, upon closer inspection, we figured out that some of these events actually did not have to be orchestrated as carefully as we initially thought. So we were able to move some events out of this queue and process them in parallel. Secondly, we were able to take some of the events where the sequencing still mattered a lot and we wanted to avoid race condition. We were able to move some of them to separate and smaller queues. Third, we were able to take more advantage of in-memory caching that we already had for some of the events that took time to process. And we did some database query optimization as well. So we felt ready to try again. But we wanted to avoid having to restart the tournament from scratch, because all of these players had played for 1 hour, and up until some point, the standings were still valid. And we really didn't want to nullify that hard work of 1 hour. It would be super unfair to whoever was leading that tournament at the time, right? That our failure would nullify their achievement. So what we did was to graph the last move of every player in that tournament. So you see in the beginning, people are playing their last move on quite a steady rate. that is just people that decide to stop playing the tournament, right? People leave, they're bored, they do something else. That's normal. And then you see the huge spike, which is then told us when the technical failure we had, when did that have an impact on the players? So looking at this, we could say that if we take the standings from, let's say, 2 minutes past 8 o'clock, something like that, if we start with those standings in part 2 of the tournament, that would be fair. So that's what we did. After about 3 weeks, we restarted the tournament, or we scheduled it and restarted it. It was over the holiday period, and we wanted to accommodate organizers, so it took about 3 weeks. Then, to be doubly and triply sure that we would not have egg on our face again, we added one more thing. We added a rating restriction on the tournament. So you could only play this tournament if you had a bullet rating of 2,000 or more. And the text is red because I don't have a bullet rating of 2,000 or more. So I could play in part 1, but I was not allowed to play in part 2. So what did this mean? Well, it meant that, remember, in part 1 we had 19,000 players. In part 2 we had 7,000 players. So that also reduced, the load on the system at the time. I'm happy to tell you that the tournament was completed successfully without any technical issues. And indeed, Grandmaster Hikaru Nakamura, who you saw in the video clip, who led after part 1 of the tournament, ended up winning the first prize as well. So that was one of the higher profile scaling challenges that we have had, in Lichess history, I think. It was very stressful for the team, but we did come out stronger on the other side. So the plan for the rest of the talk is for me to walk you through the tech stack and architecture of Lichess, and I'll continue to comment on some of the scaling challenges that we've had in the last couple of years. So let's start here, and let's start with the different clients we have connecting to Lichess. We have a web client that you use when you go to lichess.org in your web browser, which is written in TypeScript, and we rely heavily on SnubDOM, which is a virtual DOM library. Then for our mobile apps, we have a separate TypeScript client, and we use Capacitor.js to deliver that as native Android and iOS apps. Then we also have quite a rich API that is accessible to anyone, which receives about 2.5 million requests per day. And if any of these clients request static assets, that goes through our CDN, which is Cloudflare, images, sounds, JavaScript, style sheets, things like that. And then you see the situation as it was a couple of years ago. So Manta is just the name of the primary server. Gray boxes are servers in this diagram. At that point, we had a single Nginx instance that would handle most HTTP and WebSocket traffic. Nginx would do TLS offloading, it would handle rate limiting for us, it would do some logging, rewrite some HTTP headers, and then pass off the requests to Lila. Now, Lila stands for Lichess in Scala. So Lichess is written in Scala, which runs on the JVM, and we use the Play web framework extensively. Now, why are we using WebSockets? What are we using WebSocket traffic for? Well, we use it for real-time events, like users challenging each other to a game. We use it for the chat that was running 1 million miles an hour. Players and spectators in one tournament can chat with each other. But most importantly, we use it for the moves in a chess game. One of the reasons is that in online chess, low latency is very important.
Okay, I'll seek a archer. Oh dear, I'm playing Hender. Let's get some soothing music for this.
played a bad game, but a lot faster.
I played a bad game, but a lot faster. That's the philosophy of Ultra Bullet. So at this point, the Nginx instance and Lila on Manta would handle more than 100,000 WebSocket connections concurrently. And we actually had a CPU problem on Manta. It was becoming a bottleneck. So the first thing we did was to add we added one and then two new Nginx instances on separate servers to handle the WebSocket traffic. And then we split out the functionality from Lila that was handling the WebSocket traffic into a new Scala service called Lila WS, which communicates with Lila over Redis pub/sub messaging. So now when two players are playing a chess game, and let's say it's Magnus Carlsen and Hikaru Nakamura, maybe you have 2,000 spectators, it is now Lila WS that's responsible for recording that move and publishing that move to all the clients that are subscribing to that game. So this whole refactoring, re-architecting maneuver reduced the CPU load on Manta by more than half. So it gave us a lot more room to grow. Now if we go back to the tournament for a moment, another thing that we noticed during this tournament was that it was expensive to serve leaderboard updates. So at the bottom of the screen, you see the top 3 of the leaderboard. And when players play in a tournament, their client is requesting information about where they are in the standings every 3 seconds. And similarly for spectators of a tournament, most likely you're interested in the top 10. So then every client is requesting, who is winning, what are their scores, every 3 seconds. So when you have a popular tournament like this, then you'll have tens of thousands of HTTP requests every second just to serve leaderboard updates, which was a little bit ridiculous. So what we did here was to write a new service in Rust that would be able to handle and answer these requests. So now they bypass everything on the primary server. They bypass the Nginx and they bypass Lila. So that took more load off of Lila. And of course, this also gives us an opportunity in the future to expand the functionality of this service, because right now it only handles the leaderboard updates. And I think we did this in January this year. We have not talked about the data layer yet, so let's do that. We use MongoDB as our primary data store. Lila communicates with a main database that is distributed across a replica set with 7 nodes. We have one primary node that we read to and write to and read from. We have 4 secondaries that are read-only, and then we have 2 secondaries that are used for backup purposes only, one with a 1-hour delay and one with a 24-hour delay. Now, a year ago, or thereabouts, we started to see problems with the synchronization within this replica set. We would query a secondary node and we would get stale data because the synchronization process had not caught up. It was taking more time than we expected. Even worse, we started to see that the synchronization process would critically fail and it would require our manual intervention to get it back up and running. So of course that was not acceptable. So what we did was to split out content from the main database to separate databases on other servers. So we moved puzzles, for instance, to a puzzle database. That's when you have a chess position and you try to guess the best move. We moved all the studies that we have on Lichess to a study database. Studies are personal collections of games, positions, moves, comments, analysis, and you can also collaborate with others in these studies. We moved all the insights data we have to an insights database, and insights is aggregated data across all of your games for a particular player. So you can look at many different types of chess statistics across all of your games. Which opening are you winning and losing with, which piece do you move the fastest or slowest, things like that. We also created a YOLO database where we moved data that we are not so concerned about. data that we can regenerate if we want to. Yeah. And this whole maneuver, again, reduced the load on the main database by more than half. So again, it solved the synchronization issue we had, at least for now, and gives us more room to grow. Then we have Elasticsearch. So on Lichess, you can search through the forum. You can search the teams that people create, for their chess clubs or for their country or different things. And you can search through games. You can look for games across many different attributes. You can search for time, the players involved, the result of the game, the opening, and we use Elasticsearch to deliver this, right? We index all the games in Elasticsearch. In 2020, we had a strange issue because players would play a game on Lichess. Then later that day or the next day, they would go to their user profile, which lists their most recent games, and the game would not be there. It was as if they hadn't played the game at all. And the reason was that the game had not been successfully added to the Elasticsearch index. Why was that? Well, we had hit the limit for the number of documents for the index. We had indexed 2.1 billion chess games at that point. So yeah, we had to fix that. Luckily, it was pretty simple to fix. We just distributed that index over 5 shards. And now we can index 11 billion games. And today we have about 5.2 billion games played and indexed in Elasticsearch. Then we have some additional services. So at the very top, we have an image processing service where we mostly rely on the Go library called PicFit. It's an open source library. So we use this for resizing and otherwise manipulating images for user profile pictures and blog thumbnails and stuff like that. Then we have a couple of Rust services for different types of analysis. So the first one is a service for opening exploration, for opening analysis. So this Rust service exposes information that we store in RocksDB about openings. We have 2 opening databases on Lichess, one for all the play that happens on Lichess and one for Grandmaster games. So yeah, the clients will then, you see the example, the first picture here, that's the opening explorer. So you can see what are the different openings called, who plays them, how often do they win, draw, or lose, and things like that. Then the next service is the Lila table-based service, which exposes information from a 7-piece table base. That means that if you have a chess position with 7 pieces or fewer, this table base will tell you what are all the moves that win, all the moves that draw, and all the moves that lose. So both of these are very useful in analysis. Yeah. Then at the bottom here, we have some smaller services. We have a Lila GIF service written in Rust, and you see the output of that in the bottom right. It can generate a GIF from any game on Lichess. And then Lila Push is responsible for sending push notifications, like, hey, it's your turn, hey, you have a game, things like that. Then we have Fishnet, which is super cool. So when you have played a game on Lichess, you'll see this blue button, where you can request a computer analysis. What happens if you click that? You wait 5, 10, 20 seconds, and you'll get this graph in return, where you see the evaluation of every move of the game. How good or bad was every move. In the background, we are using Stockfish to do this analysis. Stockfish is an open source chess engine. But the way we distribute this work is pretty cool, and that's what Fishnet is really about. So Fishnet is now written in Rust. It was written in Python before. And Fishnet is the platform or system we use to distribute this work. So we are running some Fishnet clients on our own hardware, but then we also have volunteers and contributors who run the Fishnet client on their servers or their machines. And when a user clicks this button to request analysis, that game is sent to one of these nodes. And then the analysis is done wherever that client is running using our or maybe your CPU, and then the results are sent back. So if any of you are interested to know more about how Fishnet works, or maybe you even want to consider contributing your CPU time to this analysis, you can go to lichess.org/fishnet. Then we get to some of our anti-cheating infrastructure. So let's start with Irwin at the top. Irwin runs on 3 servers and is the name of a neural network model that looks at the moves that a player is playing in a chess game and compares it to the moves that are recommended by a chess engine. So basically, the more you play like a chess engine, the more suspicious you are, and you will be flagged accordingly. Kaladin is also, Kaladin is over here. Kaladin is also a neural network model, but Kaladin looks at insights or chess statistics, as we discussed earlier. And it looks at chess statistics over a bigger amount of games and a longer period of time. We have identified about 50 useful metrics that can be used to distinguish people who play honestly and people who use chess engine assistance. And this network will evaluate all of them and flag users accordingly to how suspicious they are. I'll give you one example of one of these metrics. So if you are a normal person, not using computer assistance, you're playing honestly, and we have data across, 200, 500 games, what we are likely to see as a common and normal pattern is that you are moving your queen slower than you are moving your king. Or you're moving your king faster than you are moving your queen. Because most of the time, when you move your king, that is in simpler positions. You don't have to think as much before you make that move. But for the queen, you move your queen typically in more complex positions, and you need more time to think. So that would be the normal pattern for most honest players. If you're using chess computer assistance, we might see that you spend about the same amount of time on average, regardless of which piece you are moving. So that's one of these metrics, and then we have 49 others. Then we have CRBot. So by the way, yellow here means that Irwin and Kaladin are Python and TensorFlow, and then CRBot is also Python. And then we have the sandbag bot, which is written in Rust. So CRBot does statistical analysis of the moves in a chess game versus the engine recommended moves. And it also has some benchmarking. So if you are playing higher quality moves than the top 10 players in the world, that's suspicious. Most top players will have verified accounts as well, so that whether they are public about it or not, we will know the identity of the top players on the site. Finally, we have SandbagBot, which catches sandbaggers. That's people who lose on purpose. So some people will choose to lose on purpose because they want to lower their rating, either because they want easier opponents in the future when they are matched up, or because they want to join tournaments that have certain rating restrictions. Like you cannot join if you're over 1600, for instance. There are also a bunch of anti-cheating stuff built into Lila, but that's not part of the talk today. Finally, I want to tell you a little bit about our monitoring setup. So all of our Scala services are sending application metrics. Well, I should phrase it differently. We use Cayman to instrument all of our Scala services. So Cayman is sending application metrics to our primary metric stores, which are InfluxDB and Prometheus. For non-Scala services, they send their application metrics to a local Telegraph agent that is installed on every server. And then Telegraph is responsible for sending that information to InfluxDB and Prometheus. And then finally, for server metrics, Telegraph handles that for us. If we want to set up alerts, we do that in Prometheus. And if we want to notify our on-call staff when there are critical alerts, we use PagerDuty for that, for push notifications, SMS, email, things like that. We have 2 to 3 people on call at any time. And then finally, we use Grafana on top of our metric stores to visualize the data that we have. So I brought a couple of examples. This is one of our overview sanity check dashboards. So you'll see the CPU usage on our primary server. You'll see the number of moves made per second. If that drops, we know something is terribly wrong, if it drops suddenly. Then we have the amount of HTTP traffic and the latency for that HTTP traffic. So this is a good place to start if you're wondering if something's wrong. Then I brought one more. So I already told you that we use in-memory caching quite a lot. We have about 1,000 in-memory caches in Lila. And we monitor the performance of some of these here. So for instance, in the bottom left here, you'll see the hit rate being graphed. And in the middle here, you'll see Lila was restarted. So all the caches started from 0, and the hit rate grew over time. So I think that's probably what we had time for. This is the most complete picture we have at the moment, but I'm sure we'll do a blog post in the near future if you want more details. Some takeaways to end and to wrap this up. We haven't found the silver bullet for handling scaling challenges. We mostly try to identify what are the most pressing issues and find the solution for those. Of course, you can see some themes, right? We are moving things out of Lila. We're splitting up our main database, so splitting things up and moving things out and offloading Lila and our main server is I'm sure that will continue. We do scale vertically as well, renting better hardware, basically. And sometimes we do that for the short term, just to have a bit more time to solve the problem in the code or in the architecture, and then we scale down the hardware again. Other times we do also need to scale up the hardware for the long term. But we're very afraid of maxing out our options, right? So if we see that we're getting close to not having more options when we want to scale out vertically, we definitely avoid that. Then we know that something else has to be done. You'll see that we have a preference for languages that prioritizes safety and performance. Rust, Scala, TypeScript as well. And we value immutability and strong typing enormously across all our development. And I think that contributes to the reliability and quality of service that we have, generally speaking. We use in-memory caching a lot, which helps the performance. And the monitoring setup that we have I feel is really good. It helps us identify some issues before they pop up. And when we need to be reactive, there's always, we look at a few dashboards, and it usually helps us identify what the problem is and what the cause is. No matter what we do, no matter what you do, I guess things will break. But the good news for us is that we are working with chess. It's not life and death. So that's a good consolation when things don't work out as planned, which sometimes happens. But we are still, there's still a lot of professionalism and clever engineering that goes into Lichess, a lot of hard work. And that's also true for the non-engineering side, which I haven't talked too much about today. 125 people, super passionate, very idealistic, and spending their time making Lichess for all of us. If you want to know more about Lichess, I can recommend this talk. This is Thibaut, our founder and main developer. He spoke at this conference in 2017, so you're welcome to search this up if you did not attend that talk. Then the final slide. If you want to engage with us in any way, which I highly recommend, first link is a link that shows an overview of all our source code repositories. Then we have an open Discord server, which anyone can join. We have pretty active YouTube and Twitch channels, and we have a Twitter account as well. That's my talk. Thank you. Yep. So plan for the questions is that I'll take 5, 6 questions at once. Then I'll try to answer whatever I feel comfortable answering. But then the team is also watching this. So the team will answer the questions that I don't answer on Twitter. We have the Lichess Twitter account, and they will use Big Techday in their answers. So you can follow that to get the answers that you don't get from me. All right, so let's start with 4, 5, 6 questions.
If you could start with the architecture from scratch, what would you do differently this time?
Thank you.
So first, thank you for the talk. Technically, would it be possible to move the Stockfish fishnet analysis to the clients themselves? Possibly via WASM or something similar?
Good question.
Can you please all put your hands up that I see if we have... Okay, thank you.
Hey, thanks a lot for the talk. Obviously, all your code is open source. I'm wondering how much of the actual game data is publicly available and metadata associated with that?
Good question, because I can answer it. Okay, one more.
Also, thanks for the talk. There was a surprising amount of web servers you're using to provide the service. Could you talk about how this architecture is planned or laid out, and if it's more like a small core group thing or more community-driven thing?
That's a good question.
Another one?
Yeah.
Okay.
Hey, we are a lot of developers. What do you currently need? Do you need developers, money? How often how many GitHub issues are closed, or is there like some delay?
I really like that question.
Hello, thanks for the nice talk.
Thank you.
My question is about latency issues, especially in the very fast bullet chess games. How do you do the time measurement there? And yeah, so not disadvantaging one player if they are far away from your servers, basically, as this might be a very challenging one.
All right. Let's stop there and see what I can answer. Yeah, so let's start with the analysis. Can you move the fishnet analysis to the client side? Well, we already have client-side analysis built into the browser on Lichess using WebAssembly. But I can tell you some news about that as well, because I don't think it has been, I'm not sure if it has been published yet. It might be soon. But so, if you go to a game on Lichess today, you can click the computer analysis and you can go through fishnet and you'll get the graph. You can also enable analysis in your browser, and it will use the local CPU on your machine to do analysis of what you want to analyze. Depending on your CPU, that could be better or worse than fishnet. But still, using WebAssembly is still not as performant as it would have been to just use the local CPU outside of the browser. So what I was testing this a couple of days ago, we have developed an installer for Windows and Linux, which starts a service on your local machine, or of course you can run it somewhere else, and you can connect that to your Lichess account. And in your in-browser or in Lichess, you can then say, instead of using the WebAssembly Stockfish engine, I want to connect to this external analysis endpoint. So that way you could set up much more powerful engine that you connect to, and I'm sure there are or will be commercial solutions by third parties for this as well, maybe. For game data, yes, we publish all rated games, I think, of all variants per month as compressed files on database.lichess.org. So you can download an enormous amount of games there. And I think we also link to some cool projects where that data has been used for different types of analysis. What openings win, or what should you play when you're bad, or all kinds of things like that. So yes, we publish game data. What do we need? We need people. Scaling organizationally is still a problem. It takes some time to train people for the more involved things. Developers are always, we're always short on developers. We always wish we had more. There is an enormous amount of open issues on GitHub, and there are tags on them. So some of them say, okay, this is not Scala. So if you're not a Scala developer, you can look at those. There are tags that say, okay, this is beginner friendly. So if you want to look at those, you could do that. The biggest recommendation I can make, if you're just curious about maybe getting involved, of course, it would be checking the GitHub repositories. Lila would be the main one. But then also join our Discord, because we have developer channels in our Discord, and our current developers who have been working with Lichess for a long time, if they see serious, interested people, they will also spend their time helping you get started. So yeah, developers I think is one of the main things. We also need moderators, but that's not really something you can apply for. It's more we'll find you. Yeah, I'll leave the architecture questions for for Twitter. I think the architecture, how it is planned, there's kind of a core group that has discussions along the way. So yeah, that would be the main answer from me there. The last question was about latency. Could you remind me what it was about? Yeah, time measurement. Yes, I did want to at least mention something there as well. I don't think I can answer it fully. But on Lichess, there is an algorithm that tries to nullify the consequences of network lag. I don't understand the code. It was written by someone with a PhD a couple of years ago. I know the intended effect is to nullify any reasonable network lag. So if you pre-move in your chess game, all the time, you should not lose any time on the clock. On other chess websites, you might. Yes. Do we have more time for questions, or should we end it there? Okay, let's try one more. Maybe I'll send it to Twitter, so don't make it too hard.
Okay, I have to go here. I wasn't there.
Okay, it's about pre-moving. Does Lichess ever plan to implement multiple pre-moves? Because I lose a lot of games by someone just moving the king left and right before I can finish.
Yes. Well, that's not the answer to the question, but I do recognize what you're talking about. As far as I'm aware, there are no plans to implement multiple pre-moves. It definitely has been discussed a lot, but I think the design choice that most people favor is to only allow one pre-move. Yeah, I think that's what I'll say about that. All right, look for our other and better answers on Twitter, and yeah, thanks for coming.